Okay, we're going to be doing decimals this week, and so we've got to first find out what decimals means. Decimal. Deci is for 10. Everything goes by power of 10. Now you guys are used to numbers like 2,384. You'll notice this 8, because of where it is not an 8. You guys have learned these positions. There's the ones position, there's the tens, there's the hundreds. There's the thousands. So really this 2 doesn't represent 2, it represents 2 thousands because it's that big. Now, we're going to first talk about how to add them, then we're going to subtract them, then we're going to multiply them, then we're going to divide them. Now in adding decimals, breaking them up is actually the most important thing to do. The representation of this as 2 thousands plus 3 hundreds plus 8 tens plus 4 ones may seem quite tedious, but it actually becomes one of the most important things in addition. When we take this right here and we try to add this number to, say, 483, this is 4 hundreds plus 8 tens plus 3 ones. Now, when we add them, somebody might give you the problem that looks like this: 2,384 plus 483. And in the current math experience that you have, you're thinking, you know what? That's all right. That's all right. No, you wouldn't say that at all. You're like, no, of course not. You got to have the 3 underneath the 4. Have you ever thought about why? Why do you need the 3 under the 4? We're going to break for that in just a minute. I'm going to ask you a couple of questions. You have 5 apples plus 3 apples. You get what? Obviously, you got 8 apples going on. Okay? You have 5 penguins plus 3 penguins. You have 8 penguins. Now, the real question. What if I have 5 apples and 3 sheep? 5 apples plus 3 sheep is 8 what? We don't know. You have 5 apples and 3 sheep. You can't add things that aren't alike. So right over here, this 3 represent ones. This 8 represents how many tens you have. So when you take this 3 up here that represents how many hundreds, you're saying 3 hundreds plus 8 tens, and it doesn't work at all. That's the whole idea when you are adding decimals, that you have to line up the decimals. So when you take this and write it out, so you have a 4, 8, and a 3 right there.
Let's zoom in so we can see this. This is the ones column, so we have 4 ones and 3 ones are 7 ones. 8 tens plus 8 tens, that's 16 tens. So we have a 6 there, and we carry the 10 tens up to the hundreds column. So now we have 100 plus 300 plus 400, that is 800. And then we have 2 in the thousands column. So 2,867. Good, let's try another.
238.4 plus 7.28. Something like that. Now again, it just looks odd. You're like, that's not quite right. And that's correct. Here, this 2 represents hundreds, that 7 represents ones. You got 2 hundreds plus 7 ones. It's like adding apples and sheep. You can't do it. That's why that decimal point needs to be exactly lined up. You then write it out, 238.4 plus 7.28. The decimal point lining up, make sure that you're putting tenths with tenths, ones with ones, hundreds and hundreds. So you have 8, because you have 0 hundredths here, plus 8 hundredths. 4 tenths plus 2 tenths is 6 tenths. 8 and 7, that's 15. Again, that's 5 ones and 1 10. That's a 4, and then we have 2, so 245.68. Let's write that up right now. You have to add like things. And then you get to carry by tens. As soon as you have 10 of something, it goes over to the next column. And actually, that's why we're dealing with decimals. When we deal with fractions in a little bit next week, we're going to be able to deal with things that are not in tens.
All right, let's have some practice problems.
To the boards! Welcome back to the boards. We're going to practice some addition of decimals. We have two problems here for you. We'd like you to use the three procedures. First of all, make sure to line up the decimals. Then add in the columns. And lastly, carry by tens if needed. Go ahead and pause the video now and try these problems. When you're ready to check your answers, click the unpause button. Okay, let's see how you did. Question number 1. I need to take this 4.26 and add it to 3.119. The first thing you want to do is line up those decimals. So I lined up the ones column, I lined up my decimal points, I lined up my tenths column and my hundredths column and my thousandths column. In fact, this first number doesn't have a thousandths, so you could include a 0 if you'd like. Now we need to add the columns. So when I add this column, I get 9. When I add this column, 6 plus 1, I get 7. 2 plus 1 is 3. And 4 plus 3 is 7. So my final answer is 7.379. Notice that I didn't have to do any carrying by 10 on that problem. Okay, let's try the next one. We have 327.195 plus 13.298. Okay, so let's work on that. First of all, we need to line up the decimals, and everything is lined up, so we're good there. Now let's add the columns. 5 plus 8 is 13, so I carry the 1 for 13. 9 plus 9 is 18, plus 1 more is 19. That's going to carry the 1 for 19. And then 1 plus 2 is 3, plus another one is 4. Good. 7 plus 3 is 10, so I'm going to carry the 10 into the next column. 2 plus 1 is 3, plus 1 more is 4. And then 3, there's nothing down here, so we just have 3. Our final answer there is 340.493. Nice work at the boards. Keep working hard in this section.
Subtraction, same thing. You got to do with like things, but this time instead of carrying, you're going to borrow. Let's make sure we've got that idea. With subtraction, we want to make sure you understand that it's more like cashing in. Like when you're borrowing and carrying, you're exchanging some things. So I'm going to put up here some money. 258.36 minus 4.38. Now again, we have to have those decimals lined up exactly where they need to go. So let's put that where it should go. Now, here's where we get to the borrowing idea. Here we have 6 pennies. We got to try to take away 8 of those. We can't really do that too well, because if you only have 6, you can't really take away more than 6 of them. So here's where we get the idea that if we take one of these, dimes, for example, so we cut it down to 2, and take those 10 and cash it in for 10 pennies. Then we have that right there. 16 of them now, minus 8 gives us 8.
If there are any among you who have had trouble seeing how borrowing and regrouping takes place and have struggled with the idea of cashing stuff in, a visual representation of this may be very beneficial. So here we have that problem, 258.36 minus 4.38. And this has an actual representation. We'll do it with United States currency. Here we have 2 hundreds, 5 actual $10 bills, 1, 2, 3, 4, 5, 6, 7, 8 actual $1 bills, 3 tenths of a dollar, those are dimes, where they are 10 cents, 10 cents, 10 cents, which are 1/10 of a dollar, and then 6 pennies, which are hundredths of a dollar, or 1 cent, 0.01 of a dollar. So these numbers in these place values have very real life meaning. So if we were to subtract this, we have 258 and 36 cents, and we're going to take away $4.38. So here's the idea of borrowing. We have 6 pennies, and we're trying to take away 8 pennies. And in the instruction, we said, oh, we must borrow from here, make that 2, and make that 16. Let's watch what happens visually. We have 6 pennies that we're trying to take away 8 from. Well, we don't have the ability to take away 8 pennies. So we take this 1 dime, right here, and we're going to change him in. 1 dime is how many pennies? Well, it's 10 pennies. So we give up this 1 dime and change it into pennies. So as we look at that, look, we now have that 1 dime, that tenth of a dollar, got changed into 10 pennies. And so we now have 10 plus 6, 16 pennies. And that's where that 16 comes from, is that dime changed into 10 of them. Now, it's very nice. We can do and take away 8 of them very quickly. 1, 2, 3, 4, 5, 6, 7, 8. And we're left with 1, 2, 3, 4, 5, 6, 7, 8. That's 16 minus 8 gives us 8 pennies. Now when we go to the next column, we're trying to take away 3 dimes, but we only have 2 left. And so in the instruction video, you were told to borrow down to 7, and that gave 10 over here. Let's watch the visual representation of that as well. We take away $1. Let's take away this guy right here. Yeah, and he gets changed into 10 dimes, 10 tenths of a dollar. Great, now we've changed that $1 in. We've gone to the bank, changed him in, and look, we have 10 more dimes. Ta-da! And so now we can take away what it says to. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dimes. We can now easily take away 3 of them. 1, 2, 3. Look at that. We can take away 3 of them, and we have how many left? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 left. 12 minus 3 was 9. Exactly. Now we're over in the dollars, the ones column, and we have $7 left, and we need to take away 1, 2, 3, 4. We don't need to borrow at all, and we can do that. 7 minus 4 was, well, we have 1, 2, 3 left. And then we still have 5 tens and 2 hundreds. And notice we have 2 hundreds, 5 tens, 3 ones, and now we have 9 dimes and 8 pennies, where we started with 258.36. So that's a visual representation of how we cash in to borrow so that we can take away things and never go below 0. All right, let's see it finished on the board now.
Then we run into a problem here. 2 minus 3. You can't really do that. It doesn't go down below 0 very well. So you take one of those and it'll give you 10 of those. And that's where you get the 9, 3, 5, 2. There we go. That'll give you the basics of subtraction. So here we're going to borrow. This together, when you are carrying and borrowing, officially the name is regrouping. With subtraction, one thing we need to make sure we understand is the negative sign. Now, we've talked a little bit about it, but that little dash has caused a lot of people a lot of problems in math for many years. So I need to tell you exactly where it came from. There's a little bit of a history of numbers that goes into this. When people first invented numbers, they invented them as adjectives. They used them to describe things in nature. For example, when I came to work today, I saw trees. You have an idea of what I saw. Somewhere in your brain you have this mental picture. But it might not be exactly what I was trying to describe. So I add adjectives to that. And so I add small. I saw small trees on my way to work. And that might adjust a little bit of what you are imagining now. So I saw small yellow trees. Again, another adjective gives you more definition of what I saw. So they invented numbers so that I would not have to go out and show you exactly how many trees I have. So small, yellow, 5. 5 small yellow trees. And it gives you a clear picture of what it was. So they called all these numbers that you could describe things in nature as natural numbers. Well, they had a debate on whether or not 0 was a number. As you can imagine, if you're describing what's in nature, and you said, oh, hey, look, I've got a number of elephants standing right next to this board. No, you don't have any. They're like, exactly, 0. It describes what's not there. Well, that's what's so unique about the number 0, is you're using it to describe what is absent, what's not there. So there's this debate on whether or not 0 should be a number, and finally, the mathematicians caved in and said, okay, 0 can be like a real number. That's great, fine. We now can describe everything that's there and everything that's not there. Well, then someone came up with the idea. They said, aha, we're going to take the number 5 and we're going to subtract 8. 5 minus 8. Well, the traditionalist thinkers thought, how can you do that? If you have 5 trees and you then take away 8 of them, you're like, that doesn't make any sense. Now, many of you are familiar with a number line, which is a great way to think about this. You've got the number 5, and you're going to go this way, 1, 2, 3, 4, 5, and then you're going to keep going. That's a great way to think about it. The positives are up there, the negatives are down there. But have you ever thought that -3 there, you're like, what do you mean -3? If I were to tell you, on my way to work, I saw -3 small yellow trees, you might think me a bit odd. Have you ever considered what a rope would look like that is -10 feet long? Negatives just don't make sense in that regard. So, what does this negative actually mean? And that's what you need to understand. That this negative was created to mean other direction. So if you consider money and you have $5 or anything, this -8 is saying you are now going in debt or losing $8. And so this means you can't necessarily have -$3 in a bank account. That would be very difficult to open up the bank account and count it out, -1, -2, -3. It doesn't make sense. This just means that $3 is now in debt. When altitude, you have sea level is kind of 0. You can have 5 feet above sea level and 5 feet below sea level, and that makes sense. Well, the negative just tells you which direction the 5 feet is going. So this is what we're going to do with this other sign. So when we do subtraction, and we have things like -7 minus 3. Like, oh boy, what's going on with that? Well, here we have 7 going in the opposite direction. And then we're going to subtract, that way, 3. So we're down here at a -10. Whenever I have minus signs, I like to kind of think of them as tug-of-war. When you have a positive and negative, they're pulling against each other. And the stronger one is going to win. And when you have 2 negatives, as here we have a -7 minus 3. It's like having a -3 on it. They're pulling in the same direction, so this is going to pull it all the way down to the -10 right down there. Consider this with a couple of English terms to it, a couple of descriptions in words. If this means, say, debt, when you're talking about money, here you have a debt of $7, and here you are going into debt another $3. Your total debt would be 10. Makes sense like that. Another way of thinking about it is with temperature. If it is currently -7 degrees cold out there, this means it's getting colder by 3 degrees, so you're going to be down at -10. All three of those are really good ways to think about it. Number line, where you're visually, subtraction means that way, plus means you're going that way. Let's do a couple more. -18 plus 5. Now in this case, you see a -18 and a +5. They're tug-of-warring against each other. So the -18 is going to win. This one's bigger. So -18 degrees, and then it gets warmer by 5. You're up at a -13. If you had a -5 plus 18, you have the same thing going on, that these two are tug-of-warring against each other. So you're kind of subtracting them to see who wins by how much. And this time you're going to be at a +13. Let's try one more. -7 minus a -10. Now this is where this negative sign, meaning other direction, is most key. Right here we're taking -7 and we're subtracting a 10, but it going in the opposite direction. So these two going in the opposite direction means we are now going positive. If you think about it in money, we have $7 in debt, and we just lost a debt of $10. That means we just gained $10. That's where the negative goes. So that becomes a +3. Now, this little nifty contraption here is kind of nice. That you have that the 5 with the negative 18 is exactly opposite of a negative 5 with a positive 18. That's going to help you when you have tough problems such as this one. 25.68 minus 384.12. We have a major problem here. 25.68 minus 384.12. How do you do that kind of a problem? You've only got 25 and you're taking away 384. Well, you're going to end up negative, so that's the idea. Now we're going to use this key over here, and if you were to subtract these backwards, take the 384.12 and subtract that, you'll get exactly the opposite answer, just like with this. Here you had a 5 and a minus 18, gave you a negative 13. Negative 5 and a positive 18 gave you 13. So if I do this problem, 384.12, and I subtract the 25.68, this answer is going to be positive, but it will be the same number just in the other direction from this one. So what I'm going to do is, most often you've seen the subtract sign here, I'm going to put it up here just to remind me that this guy is stronger and he's going to win, but still do a subtraction. We're going to borrow like normal. 12 minus 8 is 4. 10 minus 6 is 4. 13 minus 5 is 8. 7 minus 2 is 5. And then 3 comes down here like that. And this guy was stronger, so he won. Negative 358.44. So that takes care of subtraction with decimals.
So let's have some practice problems.
Hello and welcome back to the boards. In this section, we are going to practice some subtraction of decimals. We've learned 4 procedures. First of all, make sure to put the biggest number on top. Next, line up the decimals and subtract. Third, borrow by tens if needed. And last, remember, the strongest number wins. If the biggest number was positive, your answer is going to be positive. If your biggest number was the subtraction number, then your answer will be the subtraction number. Go ahead and pause the video now and try these 2 problems in your video notebook. When you're ready to check your answers, unpause and we'll see how you did. You can pause it now. Welcome back. Let's try question number 1. The first thing we need to do is put the biggest number on top. Here we have a 16 and here we have 25. So the biggest number is 25.47. We're then going to go ahead and subtract the smaller number. When you rewrite this, make sure all your decimal values line up. So my hundredths line up, my tenths line up, my decimal point lines up, my ones column lines up, and my tens column lines up. We're now going to subtract 7 minus 4, well that's 3, and 4 minus 1, that's also 3. 5 minus 6, ooh, I can't do, so I'm going to have to borrow from the tens place. So I'm going to take this down to a 1. This becomes 15. 15 minus 6 is 9, and then 1 minus 1 is just 0. So I'm left with 9.33. I now need to check which one was my strongest. Was it the positive or the negative? Notice the negative number is stronger than the positive number, and so my final answer needs to be negative. The answer is negative 9.33. Let's try question number 2. Again, we need to put the biggest number on top. I've got 211 and 199. So the bigger number is 211, and my smaller number is 199.86. Make sure that all my decimal places line up. Yes, 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 yes. I'm going to go ahead and put a 0 here because I want everything to line up nice. Okay, now we subtract. 0 minus 6. Ooh, I can't do that. So I'm going to have to borrow from the 2. The 2 goes to 1, and that gets me 10 here in the hundredths column. 10 minus 6 is 4. Now I need to do 1 minus 8. I can't do 1 minus 8, so I'm going to have to borrow from that 1, making this 11. 11 minus 8 is 3. 0 minus 9, I can't do that, so I'm going to have to borrow here from that 1. I'm left with 10 minus 9, that's 1. 0 minus 9, can't do that either. I'm going to borrow here, making that 1. So I have 10 minus 9, that's 11. 1 minus 1, those are just gone. So I get 11.34 after I do all my borrowing. Now I need to decide which one was the strongest. I had a positive number that was 211, and then a minus number that was 199. So the stronger number is the 211, and so my answer will be positive 11.34 is my final answer. Nice work at the boards. Keep working hard.
We move on to the multiplication. So a little time sign here. Now, many of you remember doing this. We're kind of reviewing right now, but you take 5 times 8 and you get 40 and you carry that 4 up there. Now, if you ever wondered why that is, 5 times 8 is 40. That's 4 10s and 0 1s. So we put the 0 in the 1s place and the 4 in the 10s place. So now when we have 5 times 3, that's 15 10s because the 3 is in the 10s place. 3 10s plus 4 more 10s that we carried over from there. That's where we get that carrying going on. So you get 15 plus 4 is 19. So we have 19 10s, which is 9 10s and 100. So 5 times 2 is 10 plus 1 is 11. Now, you should note that when we're going to times this 4 through the whole thing, this is not a 4. Never was a 4. That 4 is in the tens place, which means that mean is 40, not 4. So, because this is a 40, we've got to have an extra 0 there. Now we can do 4 times 8 is 32. 4 times 3 is 12, plus 3 is 15. 4 times 2 is 8, plus 1 is 9. And we add those together. So this guy right here was 5 times 238. And this guy right here was 40 times 238. And so when we add them, we get 45 times 238. So we get 10,710. Now, this negative sign still means other direction. It always has. That's what it does. So if either one of these were negative, such as negative 238 times 45, we have 238 times 45 in the opposite direction becomes a negative. If they were both negative, negative 238 times a negative 45, we're taking 238 times 45 in the opposite direction, in the opposite direction. Think about what happens on the number line. If we have a number up here, like 10,710, that going in the opposite direction is down here. Now if we take that and make it go in the opposite direction, we're now, and this is where the line comes from, if you've ever heard it, 2 negatives make a positive. That's what's going on right there, is that you're taking this positive number, moving in the opposite direction to get a negative, moving in the opposite direction to get a, and it'll move it right back to the positive side. Let's do one more. 385.6 times 4.2. So we're going to do the exact same thing. 2 times 6 is 12 with a little 1. 10 plus 1 is 11. 2 times 8 is 16 plus 1 is 17. And 2 times 3 is 6 plus 1 is 7. Let's not get mixed up as we times the 4 through. So now we're going to go 4 going through those whole things. So 4 times 6. Oh, we got to make sure this is 0 because this guy is 10 times bigger than that one. So it can't line up exactly the same. 4 times 6 is 4. 2, 4 times 5 is 20. Plus 2 is a 22. 4 times 8 is 32. Plus 2 is 34. 4 times 3 is 12. Plus 3 is a 15. Then we add them up and we get 2, 5, 9, 11, 6, 1. Now here we have the number 161952. Notice that this guy right here is a tenth. And that guy right there is a tenth. When you take a tenth times a tenth, you're going to get a hundredth. So this guy right here better be in the hundredths position. So here comes the shortcut. The total number of decimal places up here, 1, 2, is going to be where you put the decimal down here. So we have 2 decimal places. In this case, it's 1619.52. Your little work on estimation is actually going to help you out here. Here we have roughly 400. Here we have 4. 400 times 4, 1600. Our answer better be somewhere around 1600 right here. If you've forgotten the rules on decimals and say, ooh, yeah, 1, 1, 1. Notice that this thing is not near 1600. It's about 16,000. The estimation gives you a good idea and says, that's where the decimal would need to be anyway. So we're right around 1600. Let's do one more of those examples. 7 times 6 is 42. 7 times 5 is 35. Plus 4 is a 39. And then we're just going to have zeros the rest of the way. So now take 2 going into 6. Make sure this is 10 times bigger than that, so we've got to have a 0. If there were 3 numbers, we'd have 2 zeros on the next level. So 2 times 6 is 2, 1, 12. 2 times 5 is 10, plus 1 is 11. We're going to have zeros back there. So now we add it. 2 plus 0 is 2. 9 plus 2 is 11. And 4, 5, and a 1. So we look at this, and now to get the decimal in the right spot, we now have 1, 2, 3, 4, 5, 6 decimal places behind the decimal. So the decimal can't be here. That'll only give us 1 spot. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is where our decimal now is. Okay, so there we have multiplication of decimals.
And let's have some practice problems.
Hello and welcome back to the boards. It's time for you to practice some problems. We have 2 multiplication of decimal problems we'd like you to try. There's 4 steps to solving these types of problems. First, you want to multiply each place value. Make sure to carry by tens. Then add all the values together. And lastly, make sure to check that your answer is in the right size. So it needs to have the same number of decimal values, and you'll want to check to see if it's positive or negative. Go ahead and pause the video now, take out your notebook, and try these 2 problems and see how you do. Okay, let's see how you did. We're going to start by multiplying by this 1 into hundredths column. So 1 times 5 is 5, 1 times 6 is 6, and 1 times 3 is 3. Okay, good. Now we need to multiply by this 4. The 4 is in the tenths column, so I need to place a 0 here because I'm starting 1 power of 10 to the left. 4 times 5 is 20, so I'm going to go 20. Carry that 2. I then do 4 times 6, which is 24, plus 2 more is 26. Carry the 2. And then 4 times 3, which is 12, plus 2 more is 14. Great. Now I need to multiply by the 2, which is in the ones column. That's 2 spots over. I'm going to need 2 zeros because it's 2 powers of 10 over. 2 times 5 is 10. Carry the 1. 2 times 6 is 12, plus 1 more is 13. Carry the 1. And 2 times 3 is 6, plus 1 more is 7. Excellent. Our goal now is to add these values together. I'm going to add straight down. 5 plus 0 is 5. 6 plus 0 is 6. 3 plus 6 is 9. 4 and 3 is 7. And 7 plus 1 is 8. And so my final answer is 879.65. I'm going to put the decimal place here because I originally had 2 decimal place values in my answer, in my question. So I need to have 2 in my answer. It was a positive times a positive, so my answer ends up being positive. So that right there, 879.65, is the answer. Let's see how you did on the next one. I'm going to start by multiplying everything by 1. 1 times 2 is 2. 1 times 5 is 5. 1 times 7 is 7. I now need to multiply by this 6, which is in the hundredths column, so I'm going to place a 0 down. 6 times 2 is 12. Carry the 1. 6 times 5 is 30, plus 1 more is 31. Carry the 3. 6 times 7 is 42, plus 3 more is 45. Now we add these values together. I carry 2 plus 0 is 2, 5 plus 2 is 7, 7 plus 1 is 8, and then I've just got this 5 and 4 here. I now need to check to make sure that my answer is the right size. In this original problem, we have 1, 2, 3, 4, 5 decimal values. So my answer needs to have 5 decimal values. So let's see, 1, 2, 3, 4. So my decimal is going to go right there because I have to have the same number of decimals in the problem. Now let's check to see if it's positive or negative. It was a negative times a positive, which means the answer is going to be negative. And so this right here is my final answer, 0.45872. Well, nice work. Thanks for going to the boards. Keep working hard in this lesson.
The final review that we're going to do is the division of decimals and being able to change things into percents. So if we had something like 238.4 divided by 0.7.
In the United States, the division algorithm is set up like this. If you learned another one with a different positioning, go ahead and use it.
Now, I don't know about you, but I don't remember my 0.7 times tables really, really well. You don't just have it running around in your head, oh, 0.7 times 13 is this, and 0.7 times 18 is that, whatever. We don't know it very well, so this isn't really comfortable and say, okay, 0.7 goes into 2 how many times? You're like, I don't know. The big secret here is that this division sign, funny that, and this division sign, when you put a number up here where that dot is, you put a number down there where that dot is, this fraction is exactly the same thing. Now, we're going to cover fractions in greater depth in just a little while, but one thing I want to review with fractions is that you can times anything on the top and the bottom and have it work, have it be the exact same thing. So if I times by 10 and times by 10, I now have 2, 3, 8, 4 on the top and 7 on the bottom, which means that this is the exact same thing as 2, 3, 8, 4 divided by 7. This then becomes the problem that you're able to do. 7 goes into 23. Aha, goes in 3 times. 3 times 7 is 21, and we subtract. 7 goes into 28 4 times. Subtract, and we get a 0. Then we drop down the 4. 7 goes into 4 0 times. Now this is where you get to change this. Instead of just saying, oh, we must have a remainder 4, put a decimal there and say, hey, let's keep going. Let's see what happens. 7 goes into, drop that one down, 40. 7 goes into 40 5 times. 5 times 7 is 35. And then you subtract. 7 goes into 50 7 times. 49. And it keeps going like that. The answers on your assignment will sometimes be rounded out at 2 decimal places or 3 decimal places. So as soon as you get an idea out there a few, go ahead and stop for a minute. All right, let's do one more problem like that. 3.687 divided by 0.6. I'm going to write it out like that, 0.6, 3687. And again, we're going to move the decimal. We're really timesing top and bottom of a fraction by 10 when we do this. So we get 6 into 3687, and the decimal is now right there. So 6 goes into 36 6 times. Multiply it down. Drop down the 8. 6 goes into 8 1 time. So we have 1 times 6 is 6, 2. And drop down the 7. 6 goes into 27 4 times. 7 minus 4 is 3. And again, we can just add as many zeros as we want to. 6 goes into 30 5 times. And it came out nice right there. So 6.145 is the answer.
Good. Let's have some examples and use the algorithm that you are most comfortable with.
Hello and welcome back to the boards. In this video, we'll be discussing division of decimals. There is a 6-step procedure in doing division by decimals. The first thing you want to do is set up and move the decimals, then add zeros if needed, divide into the first number, then multiply, subtract, and drop down the next number, and then repeat. Lastly, you need to write the answer using a remainder or a decimal. Go ahead and pause the video now and try these two problems, dividing these numbers. When you're ready to check your answer, unpause the video and we'll do it together. Oh wait, welcome back. Let's get this problem set up. I've got 632 divided by 5. I need to first set up this problem. Since there are no decimals, there's nothing that we need to do. So we can go ahead and just start dividing. I'm going to take 6 divided by 5. 6 divided by 5 is 1. So 1 times 5, that's the multiplication. And then we're going to subtract 6 and 5. That leaves me with 1. We now drop down the number 3 to get 13. 13 divided by 5, well, it'll go in 2 times. 2 times 5 is 10. We subtract those and we're left with 3. Now we drop down the number again. I'm left with 32. 32 divided by 5, well, that'll go in 6 times. 6 times 5 is 30. When we subtract that out, we're left with 2. So that right there is our remainder. And so I would go ahead and write the remainder as a fraction of 5. So it would be a remainder of 2 of 5. So it would be 126 and 2/5. You could also write this as a decimal if you wanted to. 2 divided by 5 as a decimal comes out to be 0.4. And that would be fine as well. Okay, let's try number 2. We need to set up, since this problem has decimals in it, we're going to need to move the decimal place so that there's no decimals in this problem. I'm going to move the decimal place 2 spots over on this number, which will give me -9. And since I moved it 2 spots over there, I'm going to need to move this decimal place 2 spots over. And since there was nothing there, I do need to put a 0. So we're going to be left with 4670 divided by -9. Now we can go ahead and complete the division process. So 46 divided by 9, that's 5. Leave me with 45. When we subtract, we're left with 1. Bring down to 7. 9 will go into 7 one time. Subtract that 9 out. We would be left with 8. Bring down that 0. 80 divided by 9, that'll go in 8 times. 8 times 9 is 72. When we subtract 72, we're left with 8. And so my final answer would be 518 and 8/9. Now don't forget, because we were dividing by a negative number, our answer is going to be negative. And so that should be our answer there, 518 and 8/9. Okay, nice work with division of decimals. Keep working hard in this section. We'll see you soon.
Now, one of the things that division of decimals will let us do is you can actually take a fraction, any fraction out there, and turn it into a decimal. You guys have seen this a lot when you get answers on quizzes, get scores, grades in school. You have something where you're like, okay, so I got 4 out of 5 on a quiz. And you're like, what percent is that? And again, this is a divide sign, so that's exactly what we're going to do. We're going to take 4 and divide it by 5. You notice 5 doesn't go into 4. But if you put these zeros here, you can find out exactly what decimal it is. So 5 goes into 4D 8 times. Excellent. We now have 0.8. So we're able to convert the fraction into the decimal. Let's do that on one more fraction. Make sure we're okay with that. We're going to say you got 7 out of 9. This one is going to go 9, goes into 7, a couple of decimals. Let's see what it works. 9 goes into 7. Nope. 9 goes into 70. 7 times. 7 times 9 is 63. Subtract and you get a 7. Drop it down. You're like, okay, 9 goes into 70. 7 times. 7 times 9 is 63. Subtracting, you get a 7. Drop down the 0. 9 goes into 70. And about this time, you're like, wait a minute. This sounds familiar. I think I did this before. You're starting to establish a pattern where the 7 is going to keep going forever. The symbol to represent that is a bar over the 7 like that. So 7/9 is 0.7777 repeater. If you want to, you can write it with the bar over it. That's extremely accurate. Most people write 0.778, and they'll round at some point, rounding appropriately and moving it up. Now, if you got a quiz score, 4 out of 5, we want to change everything into a percent. Now I wrote that with a little break between per and cent because per means divided by, or per, and then you have cent, which is 100. Or in other words, how many hundredths? In this guy, this is 0.8. That's 8/10. If you fill it out all the way to here, it's an 80%. And that kind of makes sense. You get 4 out of 5, you got an 80% going on. 80%, however, you'll notice the difference between this and this is when you move the decimal 2 places. So this one, changing over to a percent, would be 77.8%. Equally well, you could have written it as 77.7 with a bar over it. 5 out of 7. We're going to take 5, divide it by 7. 7 goes into 5. Nope, 7 goes into 50. 7 times. It's 49. Subtract, and we get 1, 0. 7 goes into 10 once. 3, 0. So 7 goes into 30. 4 times. It's 28. Subtract, and you get a 2. 2 times 7 would be 14, and so on. So right here, 0.714, if we move the decimal 2 places, we could write it as 71.4%. That 2 tells us that it'll round down to a 4. Okay, percents never tell you exactly the amount that is happening. They tell you a portion, but they don't tell you a real amount. So we need to talk a little bit about that. The easiest thing for you to understand, and the easiest one for students at BYU Idaho, is tithing. If you consider how much you pay in tithing, it is universal throughout the church that tithing is 10%. But if you consider how much you pay and how much your neighbor might be paying and how much your priesthood leader might be paying and the Relief Society president might be paying, they all might be different amounts. So we have that. If someone makes $250, the tithing on this, the 10%, is going to be $25. If you have $850, the tithing here, 10%, is going to be $85. And so you'll notice that even though the percents are exactly the same, you always need to know what the percent is of. And this is a huge thing. Right here, we did 10% of 850. Here, this is 10% of 250. So anytime a percent is given to you, it's not sufficient in and of itself. It doesn't tell you an amount. But what it does tell you is the portion of something, and that's what's crucial about that. So on percents, you're going to take, if we gave you something like 20% of 318, we're going to take 20%, which is 0.20. That's how you change a percent into a decimal. You're going to move the decimal back 2 places. So 0.2 of, this means times, and you have 318. Let's do it up here. 318 times 0.2. 2 times 8 is 6. 1, 2 times 1 is 2. Plus the 1 is 3. 2 times 3 is 6. We have 1 decimal place. So 20% of 318 is 63.6. 0.6.
All right, let's finish up this section with some examples of percents.
Hello and welcome back to the boards. We're working on some percent problems here. What we'd like you to do is, for these blue problems, work on converting these values to a percent. For the red problems, we'd like you to take the percents and convert them to decimals. And here in these green problems, we'd like you to apply the rules of percents to solve these different problems. You can go ahead and pause the video now, and when you're ready to check your answers, unpause it and we'll work on it together. Good luck! Okay, welcome back. Let's work on it. We're working on converting these decimals to a percent. Now, anytime you have a decimal, you're going to want to move it 2 places to the right to get a percent. So I'm going to take this decimal and move it 2 spots to the right. When I do that, I'm left with 36, and I'll write a percent sign. Let's do the same thing here on number 2. I'm going to move the decimal place 2 spots to the right. Notice that we don't have a number here, so we would add in a 0. That would get me the answer of 370%. Now 3/25 is a fraction here on number 3, and so we're going to need to convert this fraction to a decimal. Anytime you're given a fraction, make sure to convert it to a decimal first. We'll do that by putting 25 on the outside and 3 on the inside of the division. Now I know 25 can't go into 3, so I'm going to go ahead and write in a 0. That gives me a decimal point. 25 will go into 30 1 time. We'll go ahead and subtract it out. That leaves me with 5. I bring another 0 down, giving me 50. 25 will go into 50 2 times. So I'm left with the decimal 0.12. To convert that to a percent, I'm going to move the decimal place 2 spots over, and we get 12%. So those are the answers for the blue problems. Let's work on these red problems. We need to convert these percents to a decimal. Well, anytime you need to do that, you're going to move the decimal 2 places over. We're going to move it left to get a decimal. So right now the decimal point is right here, 83%. If I move it left 2 spots, that'll put it at 0.83. So 83% as a decimal is 0.83. Okay, here we have 265. I'm going to move it over 2 spots to the left. That would put it at 2.65. Now 7/8, ooh, it's a fraction. Anytime you have a fraction and you want to convert to a decimal or a percent, you got to convert it to a decimal. So let's go ahead and do 7 divided by 8. Now 8 won't go into 7, so I'm going to put a decimal point. I get 70. 8 will go into 70 8 times, giving me 64. I minus that out, I'm left with 6. Drop down another 0. 8 will go into 60 7 times. 7 times 8 is 56. That leaves me with 4. Bring down another 0. I'd have 40 divided by 8, and that's 5. Excellent. So 0.875 is what we get, and we need to convert that to a decimal. Well, that's already a decimal, so my answer is 0.875. Be aware, anytime you have a repeating fraction, a decimal, something like 0.666666, and it goes on forever, you can write that with 0.6 and a bar over it. We don't have that here on this problem. Okay, let's move on to the green problems. Here on number 1, what is 26% of 250? Now the word what means X. The word is means equals. 26%, if I convert that to a decimal, would be 0.26. And remember, the word of, that means multiplication. So for me to get this problem, all I need to do is take 0.26 times 250. When I multiply that out, I get 65. Number 2, if there's 40 people in a room and 30% of them are girls, the word of again, how many girls are in the room? Well, to do that, we're going to do 40 times 30%, which is 0.3. 3 times 0 is 0. 3 times 4 is 12. My problem has 1 decimal point in it, and so there are 12 girls in the room. The last one, we have 2 of 12 eggs are cracked. What percent is that? Now, 2 of 12 is a fraction, and so to convert this fraction to a percent, we'll actually need to do the division here. I'm going to do 2 divided by 12. Now 12 won't go into 2, so I'm going to go ahead and put a 0 in there. That gets me a decimal place. That's 1. Subtract that out. I'm left with 8. Bring down another 0. 80 divided by 12, that'll go in 6 times. And 6 times 12 is 72. So we minus out the 72. I'm left with 8 again. So when I bring that down, oh, that's interesting. I get this repeating decimal here. Now to convert a decimal to a percent, I'm going to move the decimal place 2 spots to the right. And so my final answer is going to be 16.666666, and it keeps going on forever. So I'm going to use a bar over the top of it to represent that number goes on forever. And so my answer there is 16.6 repeating percent. Okay, well, nice work on these 9 problems. Keep working hard in the section.